Most drivers think cleaning an oxygen sensor is easy. A little spray, a quick wipe, maybe a soak, and it's good as new. But that simple fix can destroy a perfectly good sensor in minutes. Once it's damaged, your car burns more fuel, loses power, and runs rough. What starts as maintenance becomes a costly mistake. These sensors are incredibly delicate, and one wrong move can throw your whole engine off balance. So stick around. We're breaking down the 7 biggest mistakes drivers make when cleaning oxygen sensors. Watch till the end. There's a bonus tip for you. It will save you money and your sensor. Number 7. Soaking the sensor in gasoline or any fuel. You've probably seen those miracle DIY videos claiming a quick bath in gasoline will dissolve all the carbon and crud. It sounds tempting, but it's one of the fastest ways to destroy your sensor. Oxygen sensors aren't just chunks of metal. They have a thin protective coating and a delicate ceramic core that measures oxygen levels with extreme precision. Gasoline quickly eats through those coatings, seeps into the tiny pores of the ceramic, and permanently ruins the sensor's ability to read exhaust gases correctly. The result? A confused engine computer, poor fuel economy, rough running, and often a flashing check engine light. Experts from major manufacturers and repair shops agree. There is no safe liquid cleaner you can pour or spray through the exhaust system. The only correct approach is to remove the sensor, inspect it carefully, and, if it's heavily contaminated or damaged, replace it. If you only see light, dry soot on the outside, a gentle wipe with a clean cloth is all you need. Always double-check with a scan tool or multimeter before spending money on a new one. Number 6. Hitting the sensor tip with brake cleaner or carb cleaner. Aerosol cleaners like brake or carb cleaner seem like a quick fix for greasy buildup, but they're far too aggressive for an oxygen sensor. These products are formulated to strip heavy grease from metal parts, not to gently clean a platinum-coated ceramic element. When they touch the sensor tip, they dissolve the thin platinum layer and eat into the ceramic underneath. Once that coating is gone, the sensor can't accurately detect oxygen levels anymore. Even worse, leftover chemical residue can linger on the surface, causing inconsistent readings long after the cleaner evaporates. Car makers such as Bosch, Denso, and NGK explicitly warn against using any aerosol sprays or wire brushes on the sensing element. If the metal shield has light soot, wipe it gently with a dry microfiber cloth. Never touch the actual tip. If the tip looks oily, black, or glazed, the problem is usually a deeper issue like a rich fuel mixture or oil burning. Fix the root cause first, then install a new sensor. Number 5. Using compressed air or a high-pressure air hose to dry or clean it. Blowing off dust or drying the sensor with an air hose feels harmless, but it can cause hidden internal damage. Modern oxygen sensors have tiny reference air channels that allow them to compare exhaust gases to outside air. A strong blast of compressed air can force dirt, moisture, or leftover cleaner deep into those channels, blocking them permanently. Once the reference air path is contaminated, the sensor gives false readings, and the engine computer adjusts the fuel mixture based on bad information, leading to rough idling, poor mileage, and increased emissions. Manufacturers are very clear: never direct compressed air at or through the sensor. If it's slightly damp from nearby cleaning, simply let it air dry naturally. Avoid heat sources too. Sudden temperature changes can crack the ceramic. Patience here prevents a sensor failure that could have been avoided. Number 4. Scrubbing, sanding, or using wire brushes on the tip. Some people think a little scrubbing will refresh the sensor, but it's actually one of the worst things you can do. The sensing element is covered with an ultra-thin layer of platinum that reacts to oxygen in the exhaust. Any kind of mechanical abrasion, wire brushing, sanding, scraping, or even rough wiping removes or damages that precious coating. Without it, the sensor becomes useless, and your engine will run inefficiently, waste fuel, and likely trigger a check engine light. All major brands, Bosch, Denso, NTK, etc., state clearly that the sensor tip should never be scrubbed or polished. For light dust on the outer shield, a soft, dry cloth is enough. If there's heavy carbon or oil buildup on the tip itself, replacement is the only safe option. Remember, oxygen sensors are not designed to be restored. They're designed to be replaced when they fail. Number 3. Using WD-40 silicone sprays or any oil-based lubricants near your oxygen sensor. It might seem like a harmless way to loosen a stubborn bolt or protect nearby parts, but spraying these products anywhere close to the sensor is one of the fastest ways to ruin it and potentially damage your catalytic converter too. The problem is that these sprays release fine mists of oil and silicone particles into the air. Those vapors drift toward the sensor's exposed tip and settle on its delicate internal elements. Once that coating builds up, the sensor can no longer accurately detect oxygen levels in the exhaust stream, a condition commonly called sensor poisoning. Worse yet, the same contaminants can travel further downstream and deposit a thin, insulating layer on the catalytic converter's honeycomb structure, severely reducing its ability to convert harmful gases. What began as a simple maintenance shortcut can quickly lead to poor engine performance, higher fuel consumption, and a very expensive repair bill. The safe approach is straightforward. Keep all lubricants, sealants, and sprays far away from the sensor's tip and its electrical connector. If you need to apply anti-seize to the threads, and only if the new sensor doesn't already have a factory-applied coating, use just a tiny amount and make sure none touches the sensing element. Many high-quality sensors from Bosch, Denso, and NTK come pre-treated, so additional compound is usually unnecessary. Avoid any product labeled as silicone around exhaust components entirely. Its fumes are especially harmful. Electrical connectors must remain completely clean and dry. Never apply grease or dielectric compound inside them. When a gasket or sealant is required, choose only those specifically marked oxygen sensor safe or O2 sensor compatible. A little extra care during installation can protect both the sensor and the catalytic converter for years to come. Number 2. Improper installation techniques. Replacing an oxygen sensor looks easy, but small mistakes during the process can dramatically shorten the life of even a brand new sensor. Over-applying anti-seize, torquing the sensor too tightly, or allowing the wiring harness to sit too close to hot exhaust components are among the most frequent causes of premature failure. The sensor's ceramic element and protective housing are designed to seal properly with the correct torque. Excessive anti-seize or over-tightening creates uneven pressure that can crack the ceramic when the exhaust heats up and expands. Another common error is installing a universal sensor and splicing the wires to match your vehicle's harness. While it saves money initially, the resistance and signal characteristics are often slightly different, causing the engine control unit, ECU, to receive inaccurate data. This leads to rough running, reduced fuel economy, and eventually another check engine light. To install a sensor correctly, always start by disconnecting the battery to prevent electrical issues. Use a torque wrench and tighten to the manufacturer's specification, typically 30 to 35 FTLB for most vehicles. Carefully route the wiring away from hot surfaces, moving parts, and sharp edges. Then secure it with the factory clips or zip ties. After installation, clear any stored fault codes and take the vehicle for several drive cycles so the ECU can fully adapt to the new sensor. Following these simple steps ensures your replacement lasts as long as the original. Number 1. Trying to clean or revive a worn-out sensor instead of replacing it. Many drivers hope to save money by cleaning an old oxygen sensor with carb cleaner, brake cleaner, or even soaking it overnight. Unfortunately, this almost never works and can actually make things worse. Once a sensor has reached the end of its service life, usually between 60,000 and 100,000 miles, the failure is almost always internal. The heater circuit burns out, the ceramic element becomes contaminated with carbon, fuel additives, or oil residues, or the sensor's response time simply slows down after years of extreme heat and vibration. Cleaning the outside won't restore the heater or remove internal deposits, and any aggressive cleaning can damage the delicate tip or alter its calibration. The engine continues to run on bad information, resulting in poor air-fuel mixture, higher emissions, reduced power, and accelerated wear on the catalytic converter. Automotive experts and manufacturers unanimously agree. Cleaning oxygen sensors is not recommended. If your scan tool shows sluggish response, flat voltage readings, or the sensor has exceeded its expected lifespan, replacement is the only reliable solution. Always choose an OEM equivalent sensor from a reputable brand such as Bosch, Denso, or NTK to ensure proper fit and performance. After installation, clear codes and allow the ECU to relearn. This restores optimal fuel economy and engine efficiency. Bonus tip: don't overlook the sensor's heater circuit. Even if the sensing tip looks perfectly clean, a weak or failed heater can cause major problems. The heater is essential for bringing the sensor up to operating temperature quickly after a cold start. If it's not working properly, the sensor sends inaccurate data during those first few minutes of driving, forcing the engine to run rich and wasting fuel while increasing emissions. To check it, use a multimeter to measure the heater resistance across the correct pins. Consult your vehicle's service manual for the exact specs. If the reading is out of range or shows an open circuit, replace the sensor. No amount of cleaning or coaxing will fix a burned-out heater. In summary, oxygen sensors are sensitive components that deserve careful handling. Avoid sprays, install them correctly, and replace them when they're truly worn out. A few minutes of proper technique can save you hundreds or even thousands of dollars in repairs down the road. Did this information help you understand your oxygen sensor better? Let us know in the comments, and don't forget to subscribe for more practical automotive tips. Thanks for watching.